Did you know that even and odd trigonometric identities can best be learned by looking at the graphs of trigonometric functions? In this video, we'll look at the graphs of sine, cosine, and tangent, and you'll find that by doing this, the even and odd trigonometric identities will be easier to remember. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. We'll start by quickly reviewing even and odd functions, see what they look like graphically, and how they're defined algebraically. Even functions are symmetric with respect to the y-axis and are defined algebraically as f of x is equal to f of minus x. Let's look at the function f of x is equal to x squared, which is graphed here. You can see that it's symmetric with respect to the y-axis since the right side is a mirror image of the left side. You can also see that f of 1 is equal to f of minus 1. A trigonometric example of an even function is cosine x. Odd functions are symmetric with respect to the origin and can be thought of as being rotated 180 degrees around the origin. Odd functions have the algebraic property that f of x is equal to minus f of minus x. Let's look at the example f of x is equal to x, which is graphed here. You can see that this function is symmetric with respect to the origin since the graph on the right half plane can be rotated 180 degrees around the origin to get the graph on the left half plane. Trigonometric examples of odd functions are sine x and tangent x. Now that we've reviewed even and odd function definitions, we're ready to start learning about even and odd trigonometric identities. These identities are also called opposite angle or negative angle identities. There are 2 even trigonometric identities and 4 odd trigonometric identities. The first even trigonometric identity is cosine of minus theta is equal to cosine of theta. This is because cosine theta is symmetric with respect to the y-axis. The graph to the right of the y-axis is a mirror image of the graph to the left of the y-axis. And f of theta is equal to f of minus theta. This can be seen as f of a is equal to f of minus a. Since secant theta is equal to 1 divided by cosine theta, the second trigonometric identity is secant of minus theta is equal to secant of theta. Let's now look at our 4 odd trigonometric identities. The first 2 odd trigonometric identities are sine of minus theta is equal to minus sine of theta, and cosecant of minus theta is equal to minus cosecant of theta. The graph of sine theta is symmetric with respect to the origin or rotated 180 degrees about the origin. The graph on the right is rotated 180 degrees about the origin to get the graph on the left. Also, f of theta is equal to minus f of minus theta, so f of a is equal to minus f of minus a. Our third and fourth odd trigonometric identities are tangent of minus theta is equal to minus tangent of theta, and cotangent of minus theta is equal to minus cotangent of theta. You can see that tangent theta is symmetric about the origin because the graph on the right half plane is rotated 180 degrees about the origin to get the graph on the left half plane. We can also see that f of a is minus f of minus a. Before we do some examples, we need to look at the unit circle and see the connection between the signs of the trigonometric functions and their even and odd properties. Functions in the first quadrant have an angle of theta, and functions in the fourth quadrant have an angle of minus theta. Cosine of theta is equal to cosine of minus theta, and you can see that both of the signs are the same. Sine theta is equal to minus sine of minus theta, and you can see there that the signs are opposite. Likewise, tangent theta is equal to minus tangent of minus theta, and just like the sine function, the signs are opposite. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Let's now look at some examples where we're given a trigonometric function of a negative angle, and we need to write it in terms of a positive angle. Our first example is sine of minus 45 degrees. To write this as a positive angle, we'll use the identity sine of minus theta is equal to minus sine of theta. That tells us that sine of minus 45 degrees is equal to minus sine of 45 degrees. Our second example is cosine of minus pi over 6. We'll use the identity that cosine of minus theta is cosine of theta. This tells us that cosine of minus pi over 6 is the same as cosine of pi over 6. Our last example is tangent of minus 5 pi over 6. Our odd identity tells us that tangent of minus theta is minus tangent of theta. Tangent of minus 5 pi over 6 is then equal to minus tangent of 5 pi over 6. I think you'll be surprised how much you're going to use even and odd trigonometric identities in the future, especially if you plan on studying calculus. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.